The screen is black. Then slowly, a faint hum, the sound of your suit's oxygen pump. A voice speaks. You've just landed on Mars. The hatch opens with a hiss. A cloud of red dust swirls into the air as your boots touch the Martian soil for the very first time. History has been made. But now comes the real test: survival. Outside, the wind cuts like a knife. The thermometer on your wrist reads -60 degrees Celsius. The sky is a pale orange, and the horizon stretches out like an endless desert. You take your first step. But you know one thing. Your spacesuit is not just clothing, it's your life support. Without it, you'd be unconscious in less than a minute. For the next 24 hours, you and your crew must make the impossible possible. You need to breathe air where there is none. You need to find water on a desert planet. You need food where nothing grows. And above all, you need shelter from a world that does not want you here. Every sound your suit makes, the hiss of oxygen, the buzz of the heater, is a reminder. Everything between you and death is technology. So, how do humans survive their first 24 hours on Mars? Welcome to Astronomical Library. You glance at the gauge on your wrist. Oxygen level. Stable for now. But you know one thing. If your suit fails, Mars will kill you in seconds. The atmosphere here is 95% carbon dioxide. Oxygen, barely 0.13%. Compare that to Earth's 21%. It means that outside your helmet, there is no life. Not even the faintest chance of survival. Imagine taking off your helmet for just one breath. At first your lungs fill with toxic CO. Within 15 seconds, you lose consciousness. Within a minute, your body is shutting down. That's the reality. Mars is not a place where you can just step outside and breathe. Every single breath must be manufactured. But how? On the International Space Station, astronauts recycle air using electrolysis. They split water into oxygen and hydrogen. On Mars, scientists are developing systems to do something even bolder: turn Martian air into oxygen. In 2021, NASA tested a small golden box on the Perseverance rover called MOXIE. Its mission? To pull in Martian air full of CO and convert it into pure oxygen. And it worked. MOXIE produced enough oxygen in 1 hour for a human to breathe for 10 minutes. It doesn't sound like much. But think about it. This was the first time in history that humans created breathable air on another planet. Now scale that up. A settlement on Mars would need machines running around the clock, pumping out tons of oxygen every year. Not just for breathing, but also as fuel for rockets to return home. On Earth, you might take a deep breath without thinking. But on Mars, every breath is a gift of engineering. Every breath depends on machines that cannot fail. So here's the question. What happens if those machines break down? Do you have enough backup systems? Enough storage? Enough luck? Out here, oxygen is not just life. Oxygen is survival. Oxygen is power. The first night falls on Mars. Outside your habitat, the temperature drops to -80 degrees Celsius. Your crew runs a systems check. Oxygen is flowing. Heaters are stable. But now comes the most pressing question of all: where will you find water? On Earth, water is everywhere. Oceans, rivers, rain, even the air you breathe. On Mars, water is a treasure hidden beneath layers of dust and ice. Yes, there is water here. The poles of Mars are capped with frozen layers of ice. Scientists have also found evidence of vast underground glaciers, and even salty liquid brines trapped beneath the surface. But to use that water, humans will have to dig, drill, and melt their way through rock-hard ice in freezing temperatures. Imagine this. You need about 3 liters of water per person per day, just for drinking. Add hygiene, cooking, and farming, and suddenly a crew of 6 needs hundreds of liters every week. Shipping that from Earth? Impossible. Each kilogram of cargo costs millions of dollars to launch. So the only option is to make water on Mars. Here's how. One method is to mine ice directly and melt it. Sounds simple, but drilling into frozen ground at -60 degrees Celsius, while dust storms rage, is anything but easy. Another approach: chemically extract water from the Martian soil. Martian regolith contains minerals like perchlorates, that can release oxygen and hydrogen when heated hydrogen, that can then be turned into water. And remember, those life support systems recycling oxygen, they can also recycle water. Astronauts on the ISS already drink purified water made from recycled urine and sweat. On Mars, that technology won't just be useful, it will be essential. To give you a sense of scale, NASA estimates that 1 cubic meter of Martian ice could supply a person with drinking water for an entire year. That means finding and processing ice deposits is as valuable as discovering gold mines. On Earth, we call water the source of life. On Mars, water will be the currency of survival. It's not just about quenching thirst, it's about growing food, making fuel, producing oxygen, and sustaining a colony. So when humans finally step onto the red planet, the question will echo in every decision. Where is the water? The first 12 hours are behind you. You've secured air. You've stored a small reserve of water. But as your stomach begins to growl, another truth hits you. You can't survive on oxygen and water alone. You need food. Your supplies from Earth are limited, carefully rationed packets of freeze-dried meals. Enough for weeks, maybe months. But not for years, and definitely not for generations. If humans want to stay on Mars, they must do something truly radical. Grow food on a dead planet. Think of Mars as the most hostile farm you could imagine. The soil is toxic. Martian regolith contains perchlorates, chemicals that are deadly to plants and humans. The air is too thin, with almost no nitrogen and essential fertilizer on Earth. The sunlight is weak, barely half of what Earth receives, and the temperature swings wildly. From summer afternoons of 20 degrees Celsius to nights of 100 grados bajo cero on Earth. You can drop a seed into the ground, add water, and life begins. On Mars, nothing grows. Unless we build the conditions ourselves. That's where the idea of controlled environments comes. In greenhouses, biodomes, underground farms, enclosed spaces where humans regulate everything. Light, temperature, air, water. This isn't just science fiction. On Earth, scientists have already built prototypes. The BIOS-3 experiment in Siberia kept 3 people alive for 180 days, using plants to recycle air and produce food. NASA has been testing crops like lettuce, potatoes, and wheat in simulated Martian soil. And you probably remember The Martian, where astronaut Mark Watney famously grew potatoes using Martian dirt and his own waste as fertilizer. That's not far from reality. Human waste, recycled and treated, could provide the nitrogen plants need. LED lights could simulate the missing sunlight. Hydroponic and aeroponic systems could bypass toxic soil completely, letting crops grow in nutrient-rich water. But here's where it gets bigger than survival. Once you can farm, you can build a colony. Farms provide not just food, but oxygen through photosynthesis. Plants stabilize humidity and purify recycled water. And eventually, farming allows industry. Growing algae for biofuels, cultivating microbes that produce materials, even using plants for medicine. Imagine walking into the first Martian greenhouse. Outside, dust storms rage. The land is barren and silent. But inside, you see rows of green, living proof that life can take root in an alien world. That moment would mean more than just a meal. It would mean Mars is no longer just rock and dust. It has become a place where Earth's biology has taken hold. The first potato, the first stalk of wheat, the first salad eaten on Mars. They may sound small, but each one would be a milestone in human history. Because growing food isn't just about feeding stomachs, it's about feeding hope. And hope is the one crop humanity cannot live without. 24 hours on Mars. You've breathed the air. You've tasted the first recycled drops of water. You've sheltered from the night's cold. But behind it all, one question has been constant. Where does the power come from? On Earth, energy is everywhere. Fossil fuels, hydroelectric dams, vast grids, stretching across continents. But on Mars, you start from nothing. No power plants, no grid. Only what you bring with you, and what you can harness from the alien world around you. The first source everyone thinks of is the sun. Solar power. Mars does get sunlight, just over half of what Earth receives. More than enough to generate electricity through solar panels. In fact, NASA's rovers Spirit, Opportunity, and even the InSight lander all relied on solar. But here's the catch: dust. The fine Martian dust coats everything. It clings electrostatically to solar panels, reducing their efficiency. During planet-wide storms, sunlight drops to almost nothing for weeks. A colony depending only on solar could simply go dark. That's why most scientists and engineers are betting on another source: nuclear power. Compact nuclear reactors, like NASA's Kilopower project, could provide steady, reliable electricity for decades. A single unit the size of a trash can could power several Martian habitats, running life support, lighting greenhouses, recycling systems. Unlike solar, it doesn't matter if a storm rages outside. Inside, the lights stay on. Nuclear power has its challenges: safety, transporting reactors from Earth, but it offers something priceless on Mars: constancy. And in the long run, energy is more than survival. With enough power, you can transform Mars, run massive greenhouses, producing food year-round, drive electrolysis systems to split water into oxygen for breathing and hydrogen for rocket fuel, operate factories, 3D printing structures, refining metals from regolith, producing plastics and glass, even heat entire cities, turning frozen shelters into livable homes. Some dream bigger still. Imagine vast solar farms stretching across the equator, linked by superconducting cables, or fusion power plants, built once technology matures on Earth, or tapping into wind turbines during storms. Yes, Mars has thin air, but its winds stretch across thousands of kilometers, offering kinetic energy if harnessed correctly. But at the start, the equation is simple: energy equals survival. Every watt is precious. A single hour without power could mean frozen water pipes, suffocating habitats, dying crops. The first settlers won't just be astronauts. They'll be power managers, balancing every system like a lifeline, checking batteries, scraping dust from solar panels, monitoring nuclear cores. Because in those first days, energy isn't just electricity, it's life itself. And later, when the colony grows, when neon lights flicker in the first Martian night sky, when trains run across the desert powered by reactors, when greenhouses glow like jewels under domes, that will be the proof that humanity has lit a fire and kept it burning on another world. Because to build a civilization, you don't just need air, water, food, and shelter. You need the spark. And on Mars, that spark is energy. Day 2 on Mars. You wake up in your shelter, check the oxygen levels, and stretch your arms. But the truth is, your body has already started changing. Because Mars is not Earth, and living here means rewriting the rules of biology. The first challenge is gravity. On Mars, gravity is just 38% of Earth's. At first it feels fun. You can leap higher, carry more, move with ease. But your bones and muscles don't think it's fun. They evolved for Earth's gravity, for resistance, for weight. In lower gravity, bones weaken, muscles shrink. Within months, astronauts can lose up to 1% of bone mass per month. Without countermeasures, settlers could face brittle bones, permanent weakness, and long-term health decline. Next, radiation. On Earth, we live under a shield. Our magnetic field and thick atmosphere block most cosmic and solar radiation. Mars has neither. Here, stepping outside is like spending time inside a CT scanner every single day. Over years, this radiation raises the risk of cancer, damages DNA, and could even affect fertility and reproduction. And then there's the air itself. Mars' atmosphere is 95% carbon dioxide, with almost no oxygen. A single breach in your suit or habitat could be fatal in minutes. Settlers must carry their environment with them everywhere, like living inside a bubble that can never pop. But even if you solve air, water, food, and energy, there's another invisible enemy: the human mind. Mars is far. The trip itself takes 6 to 9 months, isolated in a small spacecraft. Once on the planet, the settlers face endless red deserts, thin skies, no oceans, no forests, no birds. Psychological strain, loneliness, depression, cabin fever could be just as dangerous as radiation or low gravity. Imagine spending years knowing you are tens of millions of kilometers from Earth, with no way home. So, how do humans fight back? exercise regimens. Colonists will need daily workouts, treadmills, resistance machines, maybe even centrifuges to simulate gravity. Radiation shielding. Habitats buried under regolith or ice can cut radiation dramatically. Some scientists propose special medications or even genetic modifications to resist cosmic rays. Medical tech. 3D printed organs, robotic surgeons, and AI doctors may become standard because hospitals on Earth are too far away. Mental health. Virtual reality could bring Earth's forests and skies into Martian habitats. Scheduled communication with Earth, community rituals, and art will be as essential as oxygen tanks. And then comes the ultimate question. Can humans not only survive on Mars, but thrive? Children born on Mars would grow up under low gravity. They might have longer, thinner bones, different muscle structures. They might never be able to return to Earth's gravity without medical support. Over generations, Martians could become something new, a branch of humanity adapted to another world. This is not just survival. This is evolution, accelerated by necessity. The Red Planet, 1T, just test human technology. It will test the very definition of what it means to be human. Because on Mars, the frontier isn't only outside, in the dust storms and frozen deserts. The frontier is also inside the human body. The clock is ticking. It has been exactly 24 hours since the first human boot pressed into Martian dust. In just a single day, the settlers have faced the greatest checklist in human history. Air to breathe, water to drink, food to sustain, shelter to protect, energy to power it all, health to keep the body and mind alive. Every one of these systems has been tested, and every one of them must hold, because here on Mars, there are no second chances. A leaking water line, a failed battery, a cracked pressure ceiling. One of these could end the mission before it begins. The first 24 hours are not just about survival. They are about proving a point, that humanity can take its first step toward becoming a multiplanetary species. But this is only the beginning. If we can endure a single day, can we endure a week, a month, a year? Can we turn fragile shelters into cities under domes? Can we transform barren deserts into fields of greenhouses glowing with life? Can we raise the first generation of children under alien skies? And perhaps the greatest question of all, will Mars become a second home, or just a heroic experiment written in dust? What the first settlers achieve in those first 24 hours will set the tone for centuries. Their courage, their mistakes, their triumphs all will echo into the future. Because Mars does not forgive weakness. Mars rewards only resilience. And in the end, if humanity is to stay, it will not be because we built machines to protect us. It will be because we learned to adapt, to endure, and to thrive on a world that was never meant for us. The first day is over. But the real story, the struggle to stay, to grow, and to build, has just begun. In the next episode, we'll move beyond the first day and ask, what does it take to build the first permanent settlement on Mars? From growing food on a massive scale, to creating industries, to building cities that can last for generations. The true test of colonization isn't just to survive, it's to build a civilization. So, what do you think? If you were one of the first settlers on Mars, what would worry you the most in those first 24 hours? Would it be the lack of oxygen? The crushing isolation? Or the thought that your body might slowly change in ways you can't control? And here's a bigger question. Do you believe humanity should even try to settle Mars, or should we focus on fixing Earth first? I'd love to hear your thoughts. Drop your ideas in the comments. I'll be reading through them. If you enjoyed this journey through the first day on Mars, make sure to give this video a like. It really helps spread the story. And if you don't want to miss the next episode, where we explore the birth of the first Martian settlement, don't forget to subscribe and hit the notification bell, because this is just the beginning, and together, we're going to witness how humanity takes its greatest leap into the unknown.